Yeah, long answer चे answer के 4 mark each ला question वाचतो first. First question show that current in. हॅलो फ्रेंड्स, कशा आहात? आज आपण महाराष्ट्र शासनाने शालेय शिक्षण व क्रीडा विभागाने 2023 मध्ये क्वेश्चन बँक पाठवली होती फिजिक्स या विषयाची. त्याची आज आपण आन्सर की बघणार आहोत. आज आपण मॅग्नेटिक फील्ड ड्यू टू इलेक्ट्रिक करंट हा चॅप्टर चालू केलेला आहे. चला तर मग ते क्वेश्चन्स बघूयात. हे लॉंग आन्सर क्वेश्चन्स आहेत, एकूण 3 आहेत. याचे आन्सर आपण पुढील प्रमाणे PDF स्वरूपात पाहूयात. हे आहेत लॉंग आन्सरचे आन्सर की 4 मार्क इचला क्वेश्चन वाचतो फर्स्ट. First question show that current in two long straight parallel wire exert force on each other drives the expression for the force per unit length on each conductor. Answer case first, both the wire carrying current in a same direction. First, consider the two long parallel wires separated by the distance d and carrying current I1 and I2 respectively, same direction same as shown in figure below. Two parallel wire distance d apart, I1 and I2 diagrams. Second, the magnetic field at a second wire due to the current I1 in the first ones according to Biot-Savart's law is B is equal to mu0 into I1 divided by 2 pi into D is equation first. Third, by the right hand rule is the direction of this field is into the plane of the paper. Fourth, force on the wire 2 because of the current I2 and the magnetic field B due to the current in wire. First, applying Lorentz force law is F is equal to I2 into bracket mu0 I1 divided by 2 pi into D into bracket integration dl. Equation second, the direction of the force in towards a wire. First, that is, it will be attractive force. 5 force of attraction per unit length of the wire will be F divided by L is equal to mu0 divided by 2 pi into I1 into I2 divided by D. Equation third. Case second, two wires carrying current in opposite direction. Force is repulsive nature between anti-parallel current and magnitude of force repulsion per unit length is into mod F divided by L is equal to mu0 divided by 2 pi I1 into I2 divided by D. Question number second. Using Biot-Savart law, obtain the expression for the magnetic induction near a straight infinitely long current carrying wire. Answer first. Consider the straight wire of the length L carrying current I. Second, length a point P suited perpendicular distance r from the wire as shown in below. Here diagram. Third, consider the infinitesimal length dl bar of wire carrying current I. The current elements ideal bar. Fourth, the current elements is suited at a distance r from point P, making an angle theta as shown in the figure above. 5. Using the Biot-Savart law, magnetic field produces dB bar at a point P due to current element ideal bar is dB bar is equal to mu0 divided by 4 pi into ideal bar into sin theta divided by r square. Equation first. Fourth, according to the properties of cross product dl bar into cross r bar indicate the direction of dB bar in this case into to the plane of paper. 7. Summing up all current element from upper half infinitely long wire. B upper is equal to integration 0 to infinity dB is equal to mu 0 divided by 4 pi integration 0 to pi infinity ideal bar into sin theta divided by r square. Equation second. 8. Taking into account of symmetry of wire, current element in lower half of infinity long wire will also contribute same as upper half, that is b lower is equal to b upper. Equation third. Ninth, according to contributions of lower and upper part, total magnetic field of point P is B is equal to 2 integration 0 to infinity dB using equation second is equal to 2 mu 0 divided by 4 pi integration 0 to infinity ideal is sin theta divided by r square. Equation first. But r is equal to integrate under root l square plus r square and sin theta is equal to sin into bracket pi minus theta is equal to r divided by r is equal to r divided by under root l square plus r square. Therefore b is equal to mu 0 into I divided by 2 pi integration 0 to infinity r dl divided by into bracket l square plus r square bracket complete under root l square plus r square is equal to mu 0 I divided by 2 pi r integration 0 to infinity dl divided by l square plus r square raised to 3 by 2. Solving the integration, b is equal to mu 0 I divided by 2 pi into r into 1 by r square is equal to mu 0 into I divided by 2 pi r. Equation 4. This equation for the magnetic field at a point suited at perpendicular distance are from the infinitely long wire carrying current I. Question number 3. Derive an expression for the axial magnetic field produced by current in a circular loop. Answer. Consider a loop for radius r carrying current I placed in x y plane with a center at origin O as shown in the figure below. Magnetic field on axis of a circular current loop of radius r आहे. डायग्राम आहे. Second, let a point P can be on z-axis at a distance r bar from line element L bar from the loop. Third, using the Biot-Savart law, the magnitude of the magnetic field dB is given by dB is equal to mu 0 divided by 4 pi into I into mod dl bar cross r bar divided by r cube. Fourth, any element at dl bar will be always perpendicular to vector r bar from the element to the point P. The element dl bar is the xy plane while the vector r bar is the xy plane. Hence, dl bar cross r bar is equal to dl into r. Therefore, dB is equal to mu 0 divided by 4 pi into I dl divided by r square. But r square is equal to r square plus z square. Therefore, dB is equal to mu 0 divided by 4 pi into I dl divided by z square plus r square. 5. Now, direction of dB bar is perpendicular to the plane formed by dl bar and r bar is the z component is dB z from and the component perpendicular to the z axis is a dB perpendicular component dB perpendicular when the submit over valued 0 as they cancel out a symmetry. Hence only z component remains. 6. The net contribution along the z axis is obtained by the integration dB z is equal to dB cos theta over the entire loop from for a figure. cos theta is equal to r divided by small r is equal to r divided by under root z square plus r square. Therefore bz is equal to integration dbz plus is equal to mu 0 divided by 4 pi into I integration dl divided by z square plus r square into cos theta is equal to mu 0 divided by 4 pi into I integration r dl divided by z square plus r square into bracket in whole square 3 by 2 is equal to mu 0 divided by 4 pi into ir divided by z into bracket z square plus r square bracket complete raised to 3 by 2 into 2 pi r. Bz is equal to mu 0 divided by 2 into ir square divided by z square plus r square raised to 3 by 2. This is the magnitude of the magnetic field due to current I in the loop of the radius r on the point P on the z axis of the loop. इथे आपले सर्व लॉंग आन्सर क्वेश्चन संपलेले आहेत. व्हिडिओ आवडला असेल तर लाईक करा, शेअर करा, सबस्क्राईब करा आणि बेल आयकॉन दाबायला विसरू नका, कारण नवीन अपडेट आपल्या चॅनलवरती तुम्हाला मिळत राहतील. धन्यवाद.